Is my audio here? Hi there. Can anyone hear me? Hello. Looks like 2 people have come. 3. Oh my god. Yeah, be right back. I don't know if the audio is active. Is the audio active? I guess I could check by clicking on my own self here and creating a loop. Yeah, be right back. I don't know if the audio is active. Yep. Now let me close that. Definitely can hear myself in the past slightly. Hello, persistent cookie. Greetings. Feel free to ask any questions. I have an iPad so I can see chat things. Very strange, but I don't want to see 2 videos of myself. That would be too much. Okay, cool. Sweet. So yeah, I'm going to go to this gameplay tab because this is a game. Coding is a game to Twitch. Everything is a game to Twitch. I have now promoted myself, and now I can get to work. Cool. So, I will first describe to you, Persistent Cookie, and the other 3 people in here with us, the mysterious people, what I'm going to start on, and also to sort of center myself. I've done this once or twice before, and it actually helped. It's sort of like a rubber ducky, or a swarm of anonymous rubber duckies, or potentially 0 rubber duckies, but as long as you don't look how many people are watching, you can imagine at least 1 rubber duck is out there mocking you. And yeah, so I'm going to tackle, or continue tackling, but really sort of restart my efforts on this PR to Izumi Reflect, which is a fast, lightweight, portable, and efficient alternative for type tag. And we use this in Zio in particular. It's part of the Zio ecosystem, but it's been created and maintained heretofore by the 7-minded friends at Septimal Mind, who are very smart and clever and have basically re-implemented the type system and the subtyping system at runtime. There's this cool blog post about it that goes into a lot of detail on the motivation and some problems they ran into and everything, and it's very cool. However, there were a few outstanding thank you for the duck noise. I glanced over at the chat. Israel. And it's great. It works in Scala too. Basically, the purpose of it is for our environment. For the has type, it's basically in Zio, it's type indexed map. So it's a map from types to implementations of those types. So if you have this value that's some has map, has of int. Oh, right before this, I was trying to get IntelliJ to work with Scala 3, but it was not giving me any syntax highlighting, so I might have to switch to VS Code, which is not my preferred IDE, but it's all right. And now these days with Copilot, that's just going to write all my code for me anyway. So let's go to iTerm, open this up code in the background, and see I even started very briefly something. Let me make this way nicer. Nice and big. Cool. So in Zio, there's this type called has, which we use, and it's basically a big bag of implementations, kind of a type level map. So if you had a map that was like, okay, you have user service was the key as a string, and it went to some implementation of user service. We don't know which one. If you had an int in there, we would have some number in here. Hey, Adam. Welcome. If you want to join me, Adam, I can also Zoom, but I'm not sure if you want to go down this painful rabbit hole. I know you're busy with your own stuff. But yeah, I'm going to work on the Zoom Reflect stuff in public, so I, don't procrastinate and get through it. But yeah, so we use, instead of using strings here, these strings are not, we can't really just use strings. That would be pretty brittle. We use these things called type tags or tags, or they're called light type tags, the things that we actually use in the implementation, but it's all the same thing. It's basically just a value representation of the type of the thing on the right-hand side. And the cool thing is we have this has map, whatever. It will actually look something like this: has user service and has int. So the value is just a map, essentially. However, the type is this intersection type that basically enumerates its contents. And so you can get this type safe accessing. So if you try to access an int by its type, it will know whether or not that is in this type and will either succeed or blow up. If you try to access a Boolean, we'll get a compiler error. Now, I'm not in the Zio project, so I don't have access to any of these things. But yeah, the type tag is the thing, and particularly a macro that we use to, at compile time, turn this type here into a value, basically into the string Boolean, we think about it, so it can look into this map and access Boolean that you have in the map there. And yeah, this is just the sort of the underlying implementation details of what powers Z layers in the environment, and was one of my favorite features, sort of the defining feature of Zio. I think it's a really unique value proposition from Zio. Anyhow, we're going to fix this up for Scala 3 because there are some issues with it, particularly when you have types with type parameters in them. So there's actually, maybe I can open up one of the files here. So ZState, or particularly in Zio. I'll go to ZState. So there's this, in Zio 2, there's going to be this thing called ZState, which is pretty cool, which is, well, models of value of type S that can be read from and written to during the execution effect. Basically, it's kind of like the state monad, except it's built into Zio using the environment, which is the way you do these things in Zio. And it's really cool. And with it, we get on the Zio companion object, update states. Yeah. You can update some state, and it's going to make sure that update state, you're going to get back a Zio effect that needs to have in the event some state of that s, whatever that type is. So you can try to add a number 1. Maybe going to the z-state spec will be the most enlightening here. So yeah, here we have some state called my state, which is just a counter, and a method called increment on it. And then we call zio.update state, parameterizing it, calling increment, which will create this. And what this actually gets back is a zio. It doesn't have the state in it. We never instantiate a state here, but before we can run this zio, we require that we provide some z-state parameterized by my state environment. And this can also have sort of multiple things in here. So you could have also had to set an int in here. And if I were to regenerate this type, it's going to require both my state and a z-state of int. And then now it's going to tell us, hey, you need to provide a z-state of int, but I'm going to remove that part. So that's nice and cool. However, in Scala 3, that update state method does not work as is. And this is because we tag every time you sort of operate on a service like this, we're going to need to access that service from the environment. And really, this is just this type level map, as we talked about. So we're going to need a key for z-state of s. The thing is, we don't know what s is at this point. Is it an int? Is it a string? We don't know. So we need to generate a tag for it, which is what this little constraint here is, this little context bound, which is really just syntactic sugar for implicit tag of s. So cool. If we have an implicit tag of s, on the implicit parameter list, okay, an implicit tag of s. So, however, that's not exactly right, because we need an implicit tag of z-state of s. Now on Scala 2, the assume reflex macro is clear enough to figure out that, okay, you have a polymorphic type here, and you have a type parameter s, and we shouldn't just generate a tag that just says, s, because that's not what it's finally going to be at the end of the day, right? It's going to be an int inside of the z-state, or it's going to be a string inside of this z-state. So in Scala 2, it's smart enough to notice the type parameter, and then in the macro generates these tags. It's going to look for, once it gets to this s, implicit tag of s in the environment, and then use that in sort of inline. However, in Scala 3, it's not currently clever enough to do that, and so it will blow up. And there are other few issues, but that's kind of the thing I'm tackling right now, is to, when you come to a polymorphic parameter, a type parameter inside of one of these tags, we're going to have to find it. And this actually it does come with some complexity. Let me see real quick, just make sure everything is good. Okay, cool. All right, so fun stuff. What have I done so far? Well, I've done a test version sort of by myself, and I've realized how I could potentially do this in Scala 3. But there's more work to be done. And I opened up a PR the other day that works, but it was a total sort of ridiculous thing, and is not actually what needs to happen. And so I got some great feedback from our 7-minded friends, and particularly here, Kai gave basically some instructions on exactly where I should be putting this code. It's a complicated code base, and I just didn't really know how to read it. Way above my pay grade. They know a lot about the Scala type system. Oh, I'm in Zio now. And yeah, there's a lot of stuff. There are all these inspectors that are doing stuff to generate light type tags to basically be able to, also another feature that we don't really need at this moment, but may in the future, is that with these tag values that are generated, they also store subtyping information, or the ability to compare whether or not one of these values is a subtype, which is sort of a massive undertaking and a lot of this complexity. Luckily, they've already done that. I don't need to do any of that. Also, luckily, there is something called tag macro in the Scala 2 implementation, and this sort of 500-line chunk of this is basically what I need to write in Scala 3. I think maybe I can try to do it in a simpler way. Maybe I don't need everything, because Scala 3, the type system, the macro system is way more principled, and especially when working with these type representations, there are more specific versions of type representations. Like they had a long time to think about it and make it better encoding of their types in the macros here. So for now in Scala 2, what was, 3 discrete concepts all rolled up into one identifier, and there are now 3 different types. So we'll take a look at what this all means. We'll sort of, I guess, learn a little bit about how the types are represented and try to get this thing to work. I should probably make a little example file as well so we can start running this stuff. So I might, right here, just make a new Scala file object called tag macro, tag macro test dots. Oh, it's already dot Scala. Okay, I'm just going to put this right here. Package is zoomy.flect, and lovely. And then here I'll probably, I don't need an object. Scala here. So I'll just def my tests. Okay. And I forget if they have this syntax, so I'll just wrap it in here. And let's just write a print line, hello, and then we can write some code that we want to run. Hopefully this is recognized by... Oh, did I put it in the wrong folder? No, it's definitely in Scala 3. But I do not see... That's great. Object testing extends app. Come on, VS Code. You can do it. I also don't get Scala format here. Or do I? I don't think I do. So all of my... All right, I might just have to do it in the terminal, which is also fun. So it's going to get some boilerplate set up, and then once this thing is running in the background, I like feedback loops very much. So let's make sure we're on Scala 3.1, and then I will bump this. It's pretty big already. The terminal does not seem to be getting any bigger. And then I will just call run main is izumi.reflect.testing. Hopefully it finds this. Did not find Izumi reflect testing. You can compile first. Oh. Projects. I wonder what project I'm in. Projects. Am I in the root? I am in Izumi reflect. I don't know which project this is. Izumi reflect. Project Izumi reflect. Maybe that one. And now I'll try to run. Running Izumi run testing. Oh, great. Oh, and I don't need to make a method then in that case. Great, so it's working. Good. Run. And you keep running there and giving us some information, and I'll do some stuff. So ideally, we want this tag macro to fire, get us what we want. So first, how does this work at all? Well, the macro recommendation here is to create a tag macro, create tag expr. So we're going to basically have this definition. This is how it works in Scala 2 as well. You basically implicitly ask for these tags. You say, hey, get me one of these tags. And you have a corresponding implicit definition that will basically summon you a tag for any type and potentially throw a compile time error if it cannot do it. But basically, you can always get a tag for any type theoretically. It should work. Or give you a guided error like it's missing. What we want to say is, hey, you need a tag for this type parameter. So we want to generate this. In particular, we're working part in here, which is the implementation. So in Scala 3, well, and we call a macro first one inline method. So I'm going to sort of make a temporary one here. It's called tag, and that's actually not so bad. But this is going to get a tag of t. And I like using the a type parameter. Maybe I'll change this, but whatever. And this is going to call. Is going to call down here, create tag expr, just in the same object with type A. Hopefully that still compiles. Yes, it does. Good. So this is going to get us an expr, which is going to get spliced into this body of code and finally getting us a tag. So an expr is basically just an abstract syntax tree, and the logic is going to be in here. And there's a sort of the strange organizational technique you probably want to use when writing Scala 3 macros, as well as in Scala 2 macro, but it's a different organizational pattern. It's a little bit of boilerplate, but it also makes it easier to abstract and pull out helper methods. I found this to be nice. So you kind of need these 3 methods. One that the user is going to call, one that's going to instantiate this class that takes this quotes thing and uses it implicitly, and you are going to import that quotes thing so you can do fancy type things and also make abstractions referring to things like type and type wrapper, which are type members of this quote reflect package. So you wouldn't have access to them otherwise. And if you don't make this external class, then you have to constantly refer to them as like ctx.reflect.type wrappers, and it's a lot of path dependent nonsense. So doing this, it makes it like you just sort of write normal Scala code inside of this block and not worry about the path dependent stuff. Okay, let's actually run something. So I have the tags, and hopefully I can create a tag. No, not that. IntelliJ, what are you doing? VS Code, val, my tag, and I'll say tag macros dot tag of, let's go int. And then my tag is my tag. My tag is my tag. And it's going to blow up because it can't find tag macros because it's tag macro. Great. And obviously there are also some other issues, but I didn't actually implement it yet. And I'm also going to restart the build server because I'm not getting any code highlighting here. But whatever, old school style, I can do this. So yeah, I'm just calling this, which is calling this, which is calling this, which is blowing up. So huzzah. Great. Now it turns out what we can start by doing, and one of the recommendations is actually to, in most cases, we're just going to call the existing architecture, the existing infrastructure here. There's this inspect thing that will generate us a light type tag, which is not quite what we need. But let me go to tag and we'll take a look at what this needs to do. So the current implementation of their implicit tag macro, I think it's tag from tag macro, yes. Dude, one size too big, zoom out. Maybe size too big. It's calling that inspect thing, and then it's getting the class of any as well. That's probably a temporary thing. I don't know why it's saying class of any, but I don't even care because we just want to preserve this existing stuff. Doesn't matter. So that's the old version. We're going to replace that eventually with our new version, but for now, in here, I'm just going to call what that thing is calling. So except in quotes to make it an expert. So it's going to create the syntax tree of calling this. No, it did not found inspect, and that's because that is inside of import dot reflection dot inspect. Oh, I guess sorry, zooming dot reflect dot reflection dot reflect. Okay, and I couldn't find a t because I've named the type A for my own alphabetical purposes. Okay, hey, my tag is a tag event, which doesn't look very special, but that is actually, if I think we can actually investigate it some and know certain things about it. This is kind of the whole point. We can even probably say option event. It's going to get us an option event tag, and I know that's covariant. It added the plus there. This is all its little rendering. I think there's a way to get the light type tag out of this, but it looks the same. And you can ask interesting questions like, is this a type of option of string? And macro tag. Oh yes, dot tag. And I could say false, but is it a subtype of option of nothing? And it's also false. Oh, an option of any. It would be true, right? So it actually can hold these things. And if I made a trait animal, and then come on VS Code, mammal, great. If I had an option of mammal, this should be the subtype of an option of an animal. It says my tag is true down there. So that's kind of cool that it can do that stuff, and that's using the tags. That's what it's doing underneath the hood, getting us this powerful thing. But it's also a value that we can use, for instance, as a key in a map. So yeah, testing mammal. Great. Pretty fancy. But what we want to be able to do is something like this. Okay. Nested tag. So I'm going to have a type parameter a here, and I'm going to have an implicit tag for that a. And then instead of doing so, I'm going to get it. I'm going to require a tag of an option of a. So I'm going to say tag macro, a tag of option of a. And so what will happen here? Nested tag of animal, or animal, who cares? Well, oh, it worked. Is that a problem? Why did that work? I might be silly here. That shouldn't work. That's what I'm trying to fix. That might not be what I'm trying to fix. Option of A. So it got the tag there, but it knew it was the tag. Maybe it's too obvious. Maybe it's inlining stuff just because it knows everything. I don't know. Generally, it would be great if I can sort of create a negative case and then fix it. I actually have this thing called oh wait, I know why it's working. It's working because I already fixed it. It's working because we're working on the branch where I fixed it in the other implementation, but we want to fix it in a different way. So that's why it's working. Hooray, okay. So let me go back and check out the develop branch. Develop, good. And let me undo my hack that works. Yes, I want to delete that commit from there. Good. So it's because I fixed it. It works. That's nice. I'm glad it still works. And now it's already not working anymore. So if you see here, it says my tag is a tag of option of A. An option of A, which is a super type of nothing and a subtype of anything, which is the default bounds that like every type parameter can have. So it's everything is less than anything and greater than nothing, because that's kind of the default. Nothing is the bottom type, any is the top type. Okay, you're saying you have a type parameter that has essentially no bounds. That make any sense? Okay. Sorry, 1 sec. All right. Cool. So that's very exciting. Okay, so that's what we want to fix. Now I got it to be broken. Now we can fix it. And the way we're going to fix it is in an interesting way. So it's basically the same thing that's done in this other Scala 2 tag macros thing, but it was a little hard for me to understand what was going on before I tried a few things myself. It's kind of cool that it can become more understandable over time, because at first I was like, I'm never going to be able to understand any of this. But if you bang your head against enough walls for long enough, it gets a little easier. So the general strategy, if I can regurgitate it successfully here, and I don't understand exactly everything that Kai is saying here, but I think I get the gist. So right now, I'm not sure if I can actually, So let me simplify it, because I'm not sure I can explain context of everything, if it'll make sense. So I'm going to try to simplify, or maybe just talk about a subproblem, even if we don't fully understand the full algorithm. It'll become clear. Okay. Well, one thing that we need to do is, instead of just delegating to the other broken implementation, this is actually okay in some cases. And in what cases would it be okay to delegate to the old implementation? Well, if, my type doesn't have any type parameters, then do this. Otherwise, we're going to have to take another tack. So I think the first step in order to simplify this problem, I really wish I had some kind of formatting. I don't know why it's not working. So in this case, we could just throw a new error and say, you got type, you got some type parameters. All right. So that's sort of the first step. If it doesn't have any type parameters, we can call this old implementation. Whether or not you understand it, it'll work, because it works if there are no type parameters. But if it does have type parameters, we have to take a different tactic. But for now, we can do this. Now, looking at the other implementation, which is probably a good place to start, they kind of are doing this. I didn't understand what this meant when I first read this a few days ago, but now that I understand context, and from suggestions that Kai gave me here, he's basically describing in this comment on my PR here, on Azure Reflect, what's happening in tag macros, which is we're trying to make a tag for some type, and then it checks, well, first it goes from this type to this representation of this type, which is called a weak type tag in Scala 2. or wait, it's called it's just called type in Scala 2 actually. In Scala 3, it's called a type repr for type representation, which I think I like a little more because the word type is a little overloaded. So you get this value version of a type, which you can query and match on and do all sorts of fancy things with. And then it asks, are all parts strong? I had no idea what all parts strong meant. It's a strong type, strongly typed versus weak typing. What does that mean? Well, pretty sure that it means that it's I'm almost positive now that it means it has no type parameters. Especially if we go to the implementation of it, am I strong? Is self strong? Well, is self strong? What is it first? The first thing it says, am I a type parameter? Is my symbol a type parameter? Or some other stuff. Am I abstract? Am I not the alias further? I don't fully understand all this. Scala 2 has a lot of issues with this macro system, so I'm hoping we don't need to do any of that stuff, or at least for the first pass. I think we could pretty much just get away with, is it a type symbol or not? Or sorry, is it a type parameter or not? But also, there could be some other problems, right? Because the outside might not be a type parameter. The inside might be a type parameter, right? There are a few different types we could sort of test this with. And maybe I could add this to this for now, just to make sure that all of these cases are going to make sense. So yeah, I have this nice nested tab thing that I can now do. Well, yeah, what case is this where what if I have a mammal of an A, right? The mammal of an A is not a type parameter, just the A part is. So we first have to sort of go into these inner types. So what is the structure of mammal A? What does that even look like? Or an option of mammal, I guess, in this case. I'll just say an option event. I don't think it's erased versus not erased. So strong versus weak. Is it like erased versus not erased? I don't think so. I mean, maybe. I don't know what terminology they're using. I am not up to. They know way more of computers than I do, and about theory than I do. I'm safe to say, but my experience with strong versus weak typing is, oh yeah, if it's like you have a static type system that's very concerned with you getting things correct, it's strong, and weak typing like, oh yeah, like JavaScript, we'll convert your string into an int because you're trying to add it. It could be in categorical terms. Yeah, that's kind of my my thoughts too. It's like there's some they're probably addressing. It's probably a very specific use of a terminology in some literature. I doubt they just came up with that word randomly. But for me, in my way I'm understanding it is that like I would make the method called my type is well I think I wrote it here, is fully concrete. Strong or strong as in strong. Yeah, there's also the strong type class as well, which is I think maybe it has to do with that. I don't even know. But we're just gonna bang our heads against the wall and try to. It's kind of fun. It's this operation in like exercise in interpretation and translation a little bit, and I'm sort of learning about how they think and how this stuff works. Now that I have some image of what the goal is. So is this fully concrete? Is basically if it is fully concrete, and maybe they will want to change this word, maybe I can make it as strong, but for my own sort of sanity as I go through this, I'm going to use a simpler language that I can understand. So is this fully concrete? And if it is, and we somehow want to pass the type A in here, but we can't. We first have to get a type repr. How do we do this? Well, you can say repr, or I'll just say type repr equals type repr of, and then you pass in the A here. Oh. I think you are right. Type tag guarantees you have a concrete type, one which doesn't contain any parameters. Weak type tag not. Oh. Okay, so that makes sense. I was always wondering why they called it a weak type tag. Hi, Funky Functor. I'm not sure if that's hello zombie or I have a question zombie or a high five. But all three of those are acceptable. High five in the meantime. So I think you are right. Type tag guarantees that you have a concrete. Okay, that's fascinating. It's a hello zombie. Oh, greetings, hello zombie. That's the zombie I want to see. So I'm on. Yeah, I'm on my iPad now. I'll do this on this computer, but I'll have to go into this tab. I'm not good at navigating all this stuff. Great. So yeah, there's a type tag and there's a weak type tag. Yeah, that's basically the thing I've always dealt with is weak type tag. But I guess confused by the difference. What's the difference? Type tag guarantees you have a concrete type, i.e. one doesn't contain any parameters or abstract type members. Weak type tag does not. Oh, okay. Yeah, okay, because you usually work with a weak type tag in Scala 2 macros. I didn't remember even, I was like, I don't know why these are all weak, but whatever. That's cool, no judgment. And yeah, that makes sense, because yes, they could contain type parameters. So I guess weak versus strong. I don't know why Scala 2 does it. So they're being consistent with the language. Probably a good idea to do that. Is not a weakling, maybe I'd call it. Is strong. Now that maybe that's proven to be something, and now I can remember that, and now we can have the sort of the in group, and we know what it means. We can confuse others. What is it called? I forget what they called it. All parts strong. So all parts strong. I've lost my own file here. Why is this one all ugly? Go back to my tag macro, please. Tag macro. Great. So all parts strong. I think it's probably a good idea to be consistent if we're going to translate it. Either very clear in simple English or consistent. And now that we vaguely understand what it means and that it isn't a word or very mathematical, we'll do it. So now we can pass in the type wrapper we got for this type into here. And there's no type int. No, there's certainly not. Great. And what's happening here? Val found. Oh, I think, yeah. I'm not on Scala. I've been writing some Scala 3 where I have all the sort of style niceties enabled. Great. All right. So if it's a part strong, it's gonna keep going, which is fine now, because now we're testing it with an int. So actually, no, we're not. It should break. It should blow up, but we haven't done it yet. So soon it will blow up, and that'll be good. Okay. So what do we want to do? Well, we want to match over this type. It could be some different structures, and I'll write them out, the different things. Well, I guess it could just be a type parameter. We're going to kind of make a recursive function that calls itself multiple times, and maybe there are other ways of doing that. It has to be recursive, because it could be, an option of an option of an option of an int, right? Of an a, right? And we still want this to not be fully strong, so that should return false. So an a should be false. An option of a should be false. What about an int and a string and an a, right? So we have intersection types. We also now have an int or a string or an a. We have union types, which are actually called and or types in this type system. So and type or type. And they have the left-hand side and the right-hand side. So they're sort of nested. So it would be maybe sort of represented as and int and string int. And thanks to Copilot, it's going to figure that out. I love Copilot so much. Or maybe on the left-hand side. Who knows how it's nested? It probably can be both, depending on how you create these types. Option. So yeah, this is, I believe, an applied type, where you have, is this right? You have some type on the right-hand side, so it would be option basically, and here would be another applied type of, it's probably 1, 2 nest, oh no, 3. It actually figured that out, that's crazy. But a simpler example of just option of A would be applied type option A. Basically, right, not entirely, because this A is its own representation of something. And we can explore what that looks like. In fact, let's just right now at the beginning print line type repr dot show. I think if we just print line, we'll see. Oh, I've broken everything. Okay, let me count that back in. So yeah, applied type. Let's take a look at it. So it's an applied type. Great. And if we delete what's in here of the A, right? Of a type ref, no prefix type A. So it's just a type reference of no prefix type A. I'm pretty sure type references also kind of work like, if you had zio.test.assertion, that would sort of be a nested chain of type ref zio of type ref test of something like this of assertion, maybe. I forget exactly. what that one is. But the important thing is we don't really care, actually. We only care about the applied type in this case, for now at least. And we basically want to go over, it's an applied type. I think we can assume left-hand side is not a type parameter, but actually that might not be true, because the left-hand side of the applied type could be a tagless final, an f of int, right? So that can actually be the type parameter, which is going to be a higher kind of tag, which maybe we don't have to worry about just yet. I'll remember to do this. But just writing some examples is a really good place to start. And we'll see. Oh yeah, and the inside was just a type ref of a term ref. So I don't exactly know where these boundaries end. I probably should make something that just renders these in a nice colored nested way. But not right now. So we have applied type, which is going to deal with that stuff, and we basically just want to check to see is the left, are all the arguments wrong? And I guess the left-hand side is also a type which could maybe have other things. So is all parts strong on that type? Is that true? So just basically just go through and recurse over these things. And finally, how do you tell if something is a type parameter? Well, you can get its type symbol, which has an isType method on it. And if it is, then we'll say true. So that's nice. And great, we made it explode. Yay! No, wait, we have match error. We have a match error. What are we missing? We're missing a type ref. Okay. If it's a type ref, we have I don't think this is correct. I think maybe it is correct. Let's see. Is that correct? No. Wrong number of arguments. Yeah. So it expected you have a typer and then a name. So it's just the right-hand side is a name. So there's a nested type and a name. We just care about the nested type. We do not care about the name. The name cannot be anything. Okay. Then we have a term ref. Term ref, which I think is similar. And we just care about this. And then we have a this type. Case this type, which I know, huh? Where are you? Are you type? Oh yeah, I think that's a type. Okay, I should probably call it type then. And then we have a no prefix. Case no prefix. False. It's not a type. I really wish I could format this. Did I make it? Hey, you got some type parameters. All right. That's pretty cool. So it's not fully strong. It's not, yeah. Maybe I'll take some notes. Oh yeah, I can repeat what I'm working on for sure. So I'm working on a solution to the Scala 3 support for Azumi reflects compile time type tag. Particularly this, there's an issue. Support assembling polymorphic tags. Oh yeah, there's a fairly involved piece of logic, tag macro in Azumi reflect, that takes care of combining this by recursively doing implicit lookups of types. This tag macro simply does not exist for the Dotty version, so until it's added, the tag evidences will not be combined in Dotty. Also, Dotty version allows invalid unresolved types, such as those type printers, to slip through without errors, but that's unrelated to separate. Okay, we're not going to be handling that. But yeah, basically it's adding the ability to have make type tags in Scala 3 that have that rely internally on type parameters. Because what you could do currently, actually, for this to work, is I could actually ask for a tag option of A. Wait, does that make any sense at all? That doesn't make any sense at all. Actually, wait, let me think. Tag option of A. Yeah, and then I can just return this tag. Yeah. And this is going to work. Why? Because when the tag is getting fired, I print out the type we're looking for here. Well, I am. Where'd it go? Well, maybe it just is working now. I have it out 3 times. Actually, I think I'd have to do something for it to rework. But now it knows that the type is an option of int at this point. Because what we're calling it, it have the int, and so now we're going to ask for implicit. The A is actually going to be an int here. In here, in internally, if we do it this way, which is something that users tend to do, so we could actually get around it by just saying, oh, users should always add a fully qualified type tag, but that means then you can't use the implicit bound syntax, which is nice, I think, sometimes. Because in here now, we're asking for explicitly the tag. This is now where the macro is firing off on an option of A, and that's the type we're actually asking for. An option of A. It does not know at compile time. At compile time here, we're executing it, trying to look for a tag of this type. It's a little complicated. Okay. Feel free to ask any other questions. Is everything good? Cool. Sweet. All right, so where'd it go? All right, so we're taking notes here. So yes, makes ensures returns true if the given type is a singleton type. Not quite. Contains no type parameters. It is not weak. And then maybe I could link to that thing. There we go. We don't want any weak types. Okay. And I'm definitely missing some cases here as well. There are more cases, but let's those just be driven out later on. This is not everything, so there will be match errors, but this will help us sort of understand the type system as we go along. Like, what are the types of types? Applied types or these sort of the dots. These are the respective dots, and I guess the difference is whether or not you're nesting into a package or an object, or maybe a path-dependent type versus an actual. You're finally referencing a type of something versus another term. So maybe it'll be like zo.test would actually be term refs, and then finally zo.test.assertion would be the type, because then we're referring to the assertion type. And this type, don't really know why that's a thing. I can explain it, I guess. The type of this. Okay. No prefix. That's sort of the nil of a chain of term refs. No prefix for type selection. Okay. So it'll be zo.s.assertion, but at the front of it there'll be hidden no prefix, kind of like that thing that sometimes you see as like root. Yes. If you do root.z. Whatever. Okay. Maybe I'll leave these notes here for now. Or maybe I could even be nice and put little examples. So that's an option of A, applied type. And A. Yay. Maybe that's more confusing, not. Anyway. I don't know how crazy to go with that kind of thing. They're probably not going to want all that information there. Okay, great. So now we can know whether or not we actually need to do work. So if we've done something and now we need to actually implement it. So we can still use for the basic cases, right? We just wanted a tag. We can get that of any type as long as it's not weak. But the second the tag is weak, it's not good, and we got to do something. Well, what can we do about it exactly? Well, that's another thing that we can ask about, which is what we want to do is eventually in the macro try to dynamically ask for an implicit. Whoa! I don't know what that sound was. This is a scary sound. It was followed. I turned my volume down. That was very scary. But thank you. You're being followed. Warning. Okay. So yeah, let's make a simple example. Oh, hey, Adam. I'm glad you're still here. That was scary. Yeah. Maybe I woke you. Took you from your open source work. Are you also streaming? All right. So yeah, an example of this. Let us do something simple about what I mean by this. So we can have. Let's make another macro real quick. Very simple macro. of, should we make another macro? Does that even make sense? It's a little weird now. What would it do? I'm actually curious myself. Let's see. Okay, I'm going to make we don't need to make another macro because you can use this. Well, what if we did this? So if we said in this block here, if it didn't, what do we try to say like summon a tag A? Technically that's going to work, right? Because the result of summon, which is the new implicitly, is going to something. And what we get is actually that's kind of interesting. Yeah, totally. So we're going to find the other definition that is implicit for tag and call that. So it's basically doing the same thing as this, because this isn't a definition of tag. But the goal eventually is to have this be the new implicit definition. This one here. Sort of this one right here. It's implicit inline def. And now, if we do this, and we import, I guess, tag macro, import tag macro dot here. Let me actually do the change so I don't have to make this too weird. So in tags on Scala 3, we currently have tag from tag macro, where it's calling this thing. Would instead now call tag macros dot tag of t, which is our new thing. Not found tag macros. Oh, tag macro. Missing parameter type. Missing type parameters for t. Am I? Oh, I have to say that any kind of thing? Let me see what inspect does. I don't know what inspect says. Oh yeah, so I might have to give it that type bound. Okay, so I'll give it type bound then. So it could be any kind as well. It can be a higher kind of type, an unapplied, a type function essentially. So this could be of any kind. I wonder if that's a new thing. I've never used any kind before. And this also needs any kind, and this also needs any kind, and not found of type T. What? Not found type T. Oh yes. Why found type T? I'm not sure why I said yes, because I don't really know. Not found type T. Oh, duh, because I'm doing that down here. Great. All right. Hey, look what's happening. We're calling ourselves recursively, because trying to summon. Not this one. Too many files. Okay. It's inlining the summon, which is going to call this again, and inlining this one, which is going to call this again, and so on and so forth. So that's not good. There has to be a better way of doing this, and it turns out there is. There's this expert.summon. So I can ask for a tag of here, and what this will return is actually a match of not quite a tag. So if we get a tag, we can simply let me command click on it. It returns us an option of an expert of that of an expert if whatever we asked for, the thing we're trying to summon. But it's not going to call itself recursively. It's just going to basically ignore the current macro scope. So it's going to let us do this without worrying about finding ourselves again and causing us just immense amounts of pain and trouble. So it's going to use some other sort of mechanism. Or at least it's not going to recurse. Maybe it's going to just try once instead of recursing multiple times. I don't really know how it works, but it's going to save us. So if we find we can use it, and that's great. If we don't, we can now throw our new error and go, oh boy. And now it says, oh boy, because we did not find that. Of course, we don't want to do this here. We don't want to do expert.summon tag of A, because we already know we don't have one of these. That's why we're calling us in the first place. We want to do it when we hit one of these type parameters. And that's where we want to ask for tag and use that expert there. But once again, we're not in the right place. We need to get to the right place first. And if we go to the other tag macros file, we can take a look at what this is doing. So if it's all parts wrong, it calls the other macro, which is what we're doing. And it's a tag, right? It's uglier Scala syntax, but it's basically the same thing, right? Let's compare. They're making a tag, but in sort of string interpolation style with a class and a tag. Here, we just get called a method sort of directly, and it even gets syntax solid for us, which is nice. Inspect.inspect is basically the old L tag macro make part light type tag impl. And closest class seems to be, we just seem to be in class of. And once again, we're asking for any, which is weird. So I think maybe that's not supported yet. I don't know. But it's what we're doing, so we're just going to delete that. We're not solving that problem if that is a problem. Otherwise, they call make tag impl. So does make tag impl do? Make tag impl. Well, there's a lot of logging, and there's some implicit error stuff that I don't fully understand. I don't think we're going to have the logging infrastructure today. They call this thing, they normalize the type in some way. They de-alias it. There's a lot of stuff you have to do in Scala too. I think they don't have to do in Scala 3, just to make things regular. It seems to be, from my experimenting, a lot more regular. We probably want to de-alias it. It's always good to de-alias things, because otherwise, it's just not going to. We're actually going to get a type that just says, like, if the type cool equals option A, we wouldn't be able to investigate this. We would see that it's an alias, it's just a type cool, rather. It would look like, type ref, no prefix, cool, which is not useful to us. So you want to de-alias it all the time, always de-alias. You can never. I was actually able to fix the other issues we were having just by, they already made a PR yesterday, where I just added like 5 de-alias, smattered around the de-aliases, threw it like roses at the code base, and full of roses. And okay, so we're going to de-alias there. All right, so just a whole bunch of noise, basically, to get the same thing again. It's just better this time. And then they check, see, is it a refined type? And they do one thing if it's a refined type, otherwise they do anything else. Now, what a refined type? Well, this is where Scala 2 is really annoying. This is an AND type. This is an intersection type. And this is actually now a list of types. So if you have a int with string with Boolean, it's going to be a list of int, string, and Boolean in here. So that's fun. Refined type. That was not easy to search for when I was trying to get that behavior for the magic stuff. It was very confusing. Like, where's the intersection type? Refined type. And these are called parents. These are the parents of the refined type. It says you can get the parents out, superclasses of the type, I guess. So this might even be for other things as well. But the example, and it probably is, but in the example they show, I was like, oh, there's the width. But that sounds terrible as a name. But there's also D1, D2, anything. I don't even know what that is. Is it a structural type? Maybe. We're not going to worry about it. So there's one way to build, we're going to make a refined type. Another one for all other cases. So I'm guessing, and I was confused about this at first, but I'm make tag with type parameters. I think this is basically the applied type case. And they handle them slightly differently. I wonder if we can handle them together. Maybe not. Let's take a look at make refined. They go through every type in that intersection, and they do the same normalization and de-aliasing. Then they summon a light type tag of the appropriate kind. And this is basically, we keep following this. Light summon tag for kind. Here, this is this implicit, infer implicit value. This is the Scala 2 equivalent of expert.summon, pretty much. I think a little here. So in here they do that, and that's basically what this is. This gets them the recursive thing. So for each of the types in there, they try to summon it. What's confusing to me is that maybe, what if they're not all parameters? Is that a problem? Maybe not, actually, because it's going to then recursively, I don't think it would recursively call this function, but maybe that's something we could actually do. Just recursive start again at every node, just call back to our original macro, and I don't know. They seem to be doing something different, so that's kind of how I think I would start, just sort of a simple version traverses it. Maybe that doesn't quite make sense. So, let me see. Okay, infer. What are they trying to infer? They're trying to infer a tag, or that's what they're doing. So it is recursively calling that macro. So basically, what this is saying, and we can write this like this in Scala 3. Basically, it's expert.summon of a tag of that type, PPE. The awkward thing is, in Scala 2, you have to use this applied type thing because they want to apply the type constructor of tag nothing, which is tag, which is a typed function because you have a tag of A. They want to turn this into a function they can apply to to their current type to get the tag of A. But all they have is type value. So there's this applied type that comes with Scala, the Scala reflect package, which will basically do that for you. It'll take the tag type constructor and apply it to the type, getting a tag of A. We have a slightly weird syntax, but it's, I think, in the end will look nice. What we can do is, let's do this. Let's make our summon tag method. So we'll have a type A here. No, we won't have a type. So the thing is, we'll have a type repr at the point. Type repr, and we want to get back an expr of a tag of, well, we don't really know at that point, actually, because we've lost what this type is. Maybe we can make a type. We'll see what happens. There's some weird in Scala 3. It's a little stricter. But really, you should see. So if we type repr and we want to get back a tag for this type repr, well, how do we do this? We want to call expr.summon, but we need a type. How do we get a type? Well, you can get a type out of a type repr by doing add type. But if you notice how you call expr.summon, well, you need to pass it in. Well, I guess we could technically. Can we do the type repr dot as? We can, and the other trick is pointless. Expr.summon does not take more parameters, so I think it is sad about that. Do not take more parameters. Yeah, I don't think we are. Oh no, because I have to say given now. We're using. Okay, let's see. Question 1 is an unknown value of a type. T is a constraint. All right, I don't fully know. Let me try something else. I wasn't sure if this was going to work. The way that I've done it before, and hopefully this works, is that you say type repr, you do as type, and then you match on it, and you do this strange thing where you match with this type match syntax, and you can get that type out like this. So we can now summon a tag of A. Oh, we get an option of a tag. Okay, good. And what if I just call get on this? And that works. Okay. It's not correct. We don't want to call get because we want to basically have a nice friendly error message. Val message. What do we got for us? Type parameter A is not supported. Not quite. Missing. Require. Whatever. Cannot. Find implicit tag of, and then we can say type.show A. That will work as well. Oh, there's software and game development category. I've been searching. I tentatively try to search a little bit on this and edit this now. It's so, their category is so weird because I was searching for like programming, and they give you like Kerbal Space Program, basic repair programming, Dyson Sphere program, militia. It's just all games. So I'm like, okay, I was thinking maybe I can come up with a clever game name. And I was like, I just put it in the relevant thing. It seems that must be new software. Oh, I think that is new. That has to be new. Because I looked, all the other Twitch streams last time I ever tried this were all science and technology. Thank you so much, Blue. First time chat. Thank you. It's so funny. Twitch is silly. Thanks for watching. Like and subscribe. I think that's possible. Definitely don't that. So, cannot find implicit tag. There we go. Good. And then we'll just call getter else. Getter else. And then we'll say report dot error and abort message. So this weird API. You don't just want to throw an error. You want to do a compiler error. And there must be a slight delay too, because I get them. So sorry if it seems I'm ignoring you for some amount of time. Really great for banner, that nice second leg. Okay, so now we try to summon a tag, and let's see. Instead of doing this one, let's call it summon tag method on on this. So summon tag of A, and what it's going to tell us. It's going to tell us method summon tag does not take macros. Oh yeah, yes, does not take type parameter. It does not, because it takes the type rep. And why is it sat there? Ooh. Does this have to, ooh. And kind. Quoted. All right, where's this sat? Here. Oh, yeah, because I'm asking for, oh, it doesn't know. Adds expert. Well, here we wouldn't use it in this case. But this is where it would be sad. Cannot find implicit. Okay, so it says cannot find implicit tag of Scala int. So it's a little weird that it did the whole thing there. But also, since we're talking to devices, a quick summary of what you're working on would be awesome. Wait, I don't have to ask you when I join this stream late. Oh yeah, I should probably have put that in like the thing, right? Isn't there like a summary field? But do I do it in the title or the go live notification? I don't know. I don't know anything. I'm scared. I'm gonna put this working on this. Scala working on this. Is that a title? That's a terrible title. Working on it. I wish there's like a description field. It looks like when it gets flattened. Working on this. There we go. Hopefully people can click on that. I'm not sure. No, cute. I really appreciate the feedback. I'd like to do this more, I think, if I have time. I'm going to be open sourcing, so it's good to, it's less lonely. And I get sucked into fewer holes. I talk to the whole time, and my wife appreciates me talking constantly. And what else? Yeah. Tag class of any inspect good. Summon tag type as expert. Okay, what time is it? Oh yeah. I could just for another maybe half an hour, and then I probably should eat food as well. Thinking of these bully things. Yeah, I would have forgotten all of that if I were just in a code hole. I have to eat food to survive. I'm a human. I'm in the animal trait. BN animal and whatnot. Oh, dog. Dang. Don't do. Oh, you did it, Copilot. How dare you? Okay. So yeah, we can find an implicit Scala int. Great. So we can get the nice error message, and we sort of summon a tag from its expert, and then we cast it. Now, it's a little weird here, but as long as we are truthful here, it's going to double check for us that we haven't lied. But if we lie, it's going to validate that we've created the right one for here. Oh man. No, truly human, flesh and blood. It's just very motivating to be around people who are really, passionate and work hard all the time. Makes you want to work harder, be less lazy. But no, I totally go through many spells of non-productivity. But this is fun stuff. It's exciting. Yeah, I'm just learning. I'm supposed to learn so much this last year. It's crazy. Since I think February or March, whenever I started the OMagic thing, really, it's like I've learned more than the other 5 years of programming combined. So tag class any inspect. Otherwise, that's. Yeah, I don't know what that face is. It's a creep. It's kind of like the guy from Spirited Away, but really, just a generic human or the android from that Will Smith android movie. Kind of looks like that too. iRobot. Anyway, Shia LaBeouf. Okay. These are all creepy faces. Anyway, back to the task at hand. So now we can do this, but we don't want to do this here. We want to do this eventually, but when we get to a parametric type here. For now, we want to sort of try to create one. I'm going to do this version first. Maybe there are only cases. I could take their advice, i.e. their implementation, and go back to tag impl or whatever, make tag impl. So really they seem to care, is it a refined type, is it an and type, or is it an applied type? I guess in any other case, it's impossible to nest down in Scala 2. Probably not entirely true. There's probably something else. maybe this make type with type parameters is going to be more interesting. Yeah. So get constructor kind if constructor is a type parameter. So that's fascinating. So if and what is this even doing? Wait a second. How is this? I'm confused because it's like a nested. All right, tricky. There's a nested block here. So they're getting the tag, potentially a higher kind of tag of the constructor. So that's actually one of the cool things, very powerful and complicated things about this library, which is that you can get a constructor, like a higher kind of tag, just for option, an unapplied option. It's this type function. And then you can apply that. So sort of like that's applied thing we were just looking at, applied type or whatever. This thing that comes from Scala, where you can apply type to its type parameters. You can do that at the value level. So it looks like they're getting a higher kind of tag for whatever the constructor is. And it could also be higher. It could also be a type parameter as well. So it looks like, there's that strong type again. So it's not a strong type. We're not going to worry about this yet, but I think that's probably why they separate this here. It's because it's slightly more complicated depending on the cases. But let's just try to do something silly at first, something we can finish and get like to a save point at. So let us, I don't know, what do they call it? Create tag expert. It's hard to name these things, right? Just kind of get more specific and longer names. I'll steal our make tag thing. And we have a type repr, and we want to get a tag of some kind of type here. Maybe I'll do the question mark again, because I just don't know. Okay, and hopefully that's enough. So basically we want to match on again. We want to match on the structure again. And we're going to say make tag of the typer. Okay, and I'm going to, let's do this. Let's just copy this for now, because we have some of the structure for type, and we'll think about what to do in each case. So here, if it's the type param, this is sort of our base case. We want to summon a tag for our x, right? That's easy. If it's an applied type, we want to do something different. And we actually want to get a tag for this. So how are we going to do that? If it's an n type, an or type, a type ref, I guess in all these cases, maybe it doesn't quite make sense. Or you just kind of recurse to this topple function, essentially, going through this whole implicit macro. That's what they're doing. They're calling this summon tag a lot. It can also summon, in some cases, a higher kind of tag, maybe? I don't know. Well, to do that, we're ever going to get an expert tag from here. We can get a tag for the left-hand side and a tag for the right-hand side. So let's focus on and cases, right? We can get a tag, make tag for the left-hand side, and we can make tag for the right-hand side, potentially. But how do we do them together? So let's take a look at their tag macro. Refined, make refined, make refined. There we go. So they recurse, basically. They summon a tag. Oh, this summons light type tag, appropriate kind. I wonder if that will be. It doesn't really matter, actually. Summon light. How are they doing this, actually? Okay, summon light type tag of appropriate kind. LTT from tag. Oh, they're calling this. Okay, so they're getting the tag, and then they're calling LT from tag, which is simply, yes, dot chaining the tag on light type tag. Because if you have an expression of a tag, well, calling dot tag on that expression is going to be an expression that's going to project the light type tag. So they're actually getting a tag, but then they're calling that thing. You can get a little mind bendy with the macros, but it's almost simple in a way. It's very fun. I've clearly enjoyed doing macro stuff lately. Cool. So we could just get an expert like this and then call on this expert dot tag. Well, let's do that same thing. Good step tutorial on macros? That's a great question. There probably aren't any, but that would be really fun to do. Adam and I did do one of the, if you go to scala.school and you search for, and you click on the macros thing, we talked a little bit about Scala 3 macros here, and we struggled through some very simple ones and talked our way through it. So we kind of did this. It's a two-part. It follows up from one we did on geo optics. So we're basically making some macros for an optics library that Adam made. So that's what we did on it. There isn't a lot out there, and when I was writing Zeomatic, I basically just read a lot of other people's macro code and just started very simple, and just looked at these big libraries that used macros. But the syntax can be so alienating, especially in Scala 2, where it's just like, I mean, first of all, the C dot everywhere, and there's this macro keyword, and what is even happening, and all the names get really weird. Weak type tag, like the weak, what the heck is that? I was just so terrified when I first encountered macro code. I was never going to learn it. But it gets easier over time. The tip I'd give is like the way to think about macros in general is that you are really, it's almost like string program. You're getting some ASTs, you're getting some valuable representation. And to think really simply, you're getting a string that code that the user wrote. So maybe, okay, it's different here. We're working with types. So you're getting some structure of the type, and your job is in this macro to spit out a code string that's going to go here. So you're really just generating a code string, and you're manipulating code strings. And one of these ways of doing it is, like, for instance, here we're going to get back an expr of a tag. What is it's basically like a code string that represents in Scala a tag. So if you had an expr of an int, what could that be? Well, it could be so much, right? It could be the number 123. It could be 123 plus 500 and something. It'd be like some sort of student dot grades dot head dot toInt or whatever. As long as it's basically some code expression that eventually will resolve in an int. Show you some clever stuff. So in our case here, that sort of, we want to make a light type tag from a tag. Let's do this. So def LTT from tag. I think that's kind of what their name was. I might change names eventually, but for now that's fine. So tag expr. Can you generate it for me? Text tag. So this would be an expr of a tag of something. And actually, we could even say a tag of A here. Do we need to say type then? No, I'm not sure. And we want to make an expr of a light type tag. And it actually doesn't matter about the A because we're not using it at all. So how can we do this? Well, imagine this were just a string. Imagine tag expr were a string that was like maybe a reference to some previous my tag was a tag. Right? That's one way of doing it. It could also be like, a tag, and it could be this and do all this stuff, right? Who knows what a tag takes? But let's just pretend an identifier. How could we take this string that represents a tag and make it into a string that represents a light type tag? Well, we know that there's .tag method on tag that returns a tag. So we just sort of change the string to index into that field, and it will do that for us. So that's kind of what we have to do here. And you can, in the syntax in Scala 3, really lovely, basically it's like string interpolation or AST interpolation. We are going to splice in, it's called splice, that $sign in, the tag expr. So basically like taking that my tag thing, putting it in there, and then we can just call out tag on it. And will it blow up? What have I done? Oh, I have an equal sign. Great. Oh yeah, that whole method down there is broken. But I think everything else is cool. Oh, and I have to say as expr of tag of A. Okay. But yeah, it would be fun to do macro stuff, especially with Scala 3 macros being pretty cool, and I have a lot of ideas for things. So I want to, maybe we could do more series on that. Although I work with Alex Yaffe, who's the creator of Quill and a super macro wizard genius. Quill is a database library that's just built at macros itself. And we're going to have him on our symposium Friday talking about Quill. Probably won't go too deep into the implementation, but I'm sure he'll touch on it a little bit. But yeah, it would be cool to collaborate with him on maybe doing a series of macro lessons or something, because they're very cool. But meanwhile, I'll do these. So this Friday, we haven't posted yet, so follow us on Twitter or what have you, and we'll put, or just the Discord, and we'll be sure to link. We've been not so great at posting these meetup links too far in advance, but it'll be Friday at 11 a.m. Pacific time, 2 p.m. Eastern time. Nice. Okay, so yeah, that's basically the implementation, right? So that's exactly what they had here. .tag, where .tag? There we go. Here. So basically the same thing. And this one looks even more like string interpretation, and basically it is, because this will let you do anything. It'll yell at you later, but Scala 3, you write a code and it's actually going to compile it like code and make sure that you're accessing something that actually exists here. Here, nothing would stop you from doing fuzzy wizard. This would break at runtime, but not at compile time. Here, it's going to let me know that fuzzy wizard is not a method on tag. Yes, that fuzzy wizard is not a member of tag, whereas tag. Why did I just that? Okay, tag is. It does not know light type tag is though, because I have not imported that. Where does light type tag exist? Light type tag. Scala.flag.macaroni. I don't know what that means. Scala import zoomy .reflect .macaroni .light type tag. Is it happy now? Yeah, it's happy. It knows what that is. Cool. Sweet. Okay. So we have a method that can just do that for us. We have this. Yeah, we're trying to figure out how to make the refined type. So make refined intersection, and then we don't know what the original I don't think we need that. Maybe we do. We'll see. So we're summoning light type tags for each one of the appropriate kind as well. Oh, interesting, because you get the light type tag. The light type tag. It's kind of like the weak. I don't know why they have light type tag. I don't know what. Maybe that's something to do with weakness. but so there's tag and there's the light type tag, and then there's the high kind of tag, which is like the thing of just option as a function, a non-opted option versus an option of int, right? So this would be on the right-hand side would be a tag, the left-hand side would be a right-hand tag. But I think inside they both have light type tags, so we don't need to worry about certain things, I guess, probably. So we're going to get the light type tag of the appropriate kind, so whether or not that is a higher kinded type or not. Cool. And then we get the intersection tags. I don't know what this is. Summoned intersection tag. Oh no, that's that. But we turn it into an expert of a list of light tags. So in order to take a list of experts and turn it into an expert of a list, right? The sequence method, if you are familiar with the whole traversable architecture, we call it flip in Zio, because if you have an F of a G of an A, it flips them. It's you a G of an F of an A. Perfect. And so we call that flip. So it's basically that. And luckily, you can actually do that. There's an expert dot of list that takes a sequence of expers and gets back an exper. So a list will get you an expert of list. So an expert, so you go from a list of experts to an expert of a list, and do that with other things as well. So we have answer for that. The only interesting thing is that for and, we kind of don't want to do this one at a time. We want to get all of them at once. So it would be great. First, we can get a list of all types inside of the end. So I'm going to make a function called def flatten end. And this is going to take a type wrapper, yeah, and this is going to get us a list of a type wrapper. And it just did it. And I don't know how it just did it, but it's smart. I did write before, but that's still crazy. Let's say flatten or. You could figure that out, right? Yeah. Okay, perfect. Man, oh man, that's so good. So now if we call flatten end, we're going to get, so end type. We'll switch over to the type pattern. We'll get a list of expers. And then we can map on this, make tag, get a whole bunch of expers of tags, which we can then, do t, dt, and then we can sort of call LTT from tag. Great. Now I'm doing the abbreviation thing. It's fun how you try to be all, descriptive and semantic, but then let's just do two-letter variable names. Now I'm inside. I know what that means. I'll never forget. So here are our LTTs, as we know. We're in the know. LTTs are pretty cool. I'm going to comment all these other things out so I can actually see if anything is compiling or not instead of it yelling at me about wrong types. How did I do that? I should have just done case question mark. Okay, so are you? Oh, and this isn't right yet. That's wrong. Okay, good. Okay, so there's definitely some issues. Yeah, because an implementation is missing for sure. Make tag. Oh yeah, that right is missing. Fine. Great. Okay, so now we have this list of like so we have an error probably. This is not going to tell me. Great. It's a list of oh, not here. Right. This is a list of expert of light generated for me. Come on. I don't know why it's not. Ah. Yes, it is. What was that? That's so weird. But almost did it. So we have this, and we want to generate we want to flip them. We want to do flip, sequence, whatever. LTDs. Okay, so we do expert dot list of list LTT0, and this should be an expert list of light typings. Great. And it's not sad about that. It's just sad about these question marks. Perfect. Cool. And then what do they do? Then they make a struct. Don't know what that's doing. And they get the closest tags. And then they create a refined tag. Now, I'm pretty sure, because I remember he told me this, there's already a combination function for intersections and refinements, tag.refine tag. So let's take a look at what that is. Tags, refine tag. Good. So what does this take? And this is Scala 3, I believe, yeah. So it takes the intersection, and it takes struct type. Do not know what that is. Uh-oh. How do I zoom out? Zoom out. Zoom out. Okay, sorry for making small, but this goes off the page. I'll need a lub class, which I don't know what that's about. I guess I could use the class of anything again. I'm not sure. What are they doing here? They are, I think, closest class of the original refinement. Okay, so maybe I should see with the original refinement, because they're also struct tag. Yeah, they're making us a type based on the original refinement. So I guess a refinement can be more than just. Where is this doing it? Okay, so it's the thing that we were using to do this in the first place. So it's sort of the parent. So we probably don't want to recurse too far. Interesting. Okay. Make struct. What does this do? Oh, it's like a map from strings to light type tags. I guess this is for, it must be for like structural types as well. But I don't think in the end type that I don't care about this. It could probably be an empty map. Struct tag. Okay, let me go back to this where I have to sort of do some interpretation. Struct type. Where are we calling? So are we ever calling refined tag? Refined tag. Oh, not really. Well, they're showing an example here. Oh yeah. So okay, totally. This is an intersection type with the structural refinement taken from struct type. So I don't think we need struct type. Shoot. That's weird. What to do there? Struct type. Is that a method we have access to? Not really. All right. It makes a tag. Light type, which makes it okay. Light type tag, refined type. Okay, what does that do then? Oh geez. I gotta go to light type tag. Refined type. Maybe intersection parts. Oh geez. And this is where it gets a little crazy. I don't think it's the intersection, it's the parts. Where does it use structure? Light type tag, refinement. So they're using, this is the Scala 2 version, they're reusing the same sort of internal architecture for the light type tags. It's not system specific, so only the macros that generate these light type tags are. It's the same internal light type thing, which probably means it can't be, probably would be nicer if it was only supporting Scala 3, but also a lot more work. Of course, Funky Funk. Thank you for joining. Take care, man. Or lady. Adios. Until next time. Okay. Yeah, this is the best part. This is where I hit a wall. It's a good time to leave. I'll see if I can't figure out a little bit of something. But yeah, I basically need to make something here. I basically need to make something. The only things I don't know. Okay. When in doubt, look at Scala 2 macro. Make struct. They get the original refinement. They get the declarations. I don't think we need any of this. I think these will both be empty lists. In my case of the and right now. Obviously, I will have to deal with that eventually, but for now, I don't need to. Resolve tags. So yeah, I'm going to assume that's an empty thing. Internal.refine type. Oh no. Make. Yeah, not sure. Resolve tag expert, resolve tags. So you don't think we care about any of that stuff? Internal.refine type. Where is this? Oh. Oh, wait a second. Oh, they're creating one in Scala. With this is an internal method. So yes, it would potentially be possible to just how we create an and type. Is it possible to make one? Because then we just make one again and then get recursively after we've gotten those, we just pack it back up and then ask for it to work on the macro that's strong. The strong macro, which will deal with it for us, and we don't need to worry about this. Okay, so going to go to the quotes file and look for and type. This is the master file of all the Scala 3 macros, and we can create one with this. Well, that's fine. We can recursively we'll fold left or fold right. I don't think it matters because it should be commutative, at least semantically. So we can take these light type tag. Wait a second. Wait, no, that doesn't make any sense. Because at this point, wait, so what are they doing? Because at this point, when you return an X for a tag, we have a whole bunch of light type tags. So we do it in the version of original refined type owner symbol. So they're okay. Oh wait. Okay, they're getting strong. They're separating out the strong from the weak declarations. For the strong ones, oh yes. Okay. So yeah, you want to separate out strong and the weak declarations. They're making so they're getting the type for the strong subset of the type. So if your type is Boolean and string and A, they're going to partition out the Boolean string from the A, and then basically create a type using the Scala type system. So we could do that. So make a type repr of just Boolean and string. For that piece, we're fine with for this we can just delegate to the other implementation because it's already possible to get that. But for the A, for the weak declarations, actually that's not quite, doesn't quite make sense to me because they're not even doing it on the, I mean, I think that's part of it, but they're doing it on the declarations, this original refinements declarations, not the intersections. So it's like another thing that they're doing. Strong decals type. Where is this again? Where are we using struct? I've lost myself. Make struct. A bunch of places. Okay. They get the intersection tags. Oh, so they use the intersection again. Okay. So they're making a struct. So yeah, because there's also a refined type is more than just an in type in Scala 2. It can also have subtypes. It can also, like a refined type can also represent, I think, structural types. And I don't know how that's happening in Scala 3. It's the same thing. I think they separated it out to and is and there's another thing that seems to be the way they did it. Made it nicer and separated so there aren't these overloaded terms. So we're going to get the struct tag additional type is fine. But what do we do with our intersection tags? Okay. We call refine tag, and the struct tag splicing. Okay. Maybe can we just pass in the same thing? We might be able to. Tag.refine tag. This takes a light type tag, but it's for a whole thing which we don't have. How does it even work? Struct tag, make struct. It works like this. There's a make parsed light type tag impl. It's basically calling in inspect. They're creating a new refined type with the intersection. The original intersection, though, not changing it to remove things. Resolve tag tags per but decals must also find at least. I don't think there's a decals, but this must also get the members of the intersection. It must. Otherwise, it doesn't make any sense. Because otherwise, it's going to try to create the same tag with the same thing. Fun. So we could create one. So we just use the same type again. That's basically what that is. Original refined type symbol owner. Don't really know. And then it's sort of saying how to resolve particular members. So we'll sort of get the light type tag for A, and then it will use that to get the type tag that we've solved separately. That's pretty complicated, and I'm not sure if I am following it, so I might need to step back and think about it. I can get this light type tags, but then I have no way of generating it, just a normal tag from, except for that somewhat confusing refined tag method. But I just don't know what to put here for the struct type. Really. A with B. Oh yeah, because you can have a type parameter that also is very complicated stuff. Like why would you probably shouldn't do that. But this could have a def inside of it, which would also have potentially another type parameter. List A tag, B tag. I did not invent lang. I don't know this kit lang. It's a highly magical. Oh, maybe it did. I like the magical. It's inactive. It was too magical. High designed for game development. Oh, cool. Oh, that's sad. They kill it. Why you should use this? Kit features modules, inputs, same package. Kit build, kit test, kit run. Exactly. Exactly. And I have my own Zeo Magic library. So I'm a fan of Magic. So I could have theoretically done this, but I would have had to be in a fugue state. In 2019, I don't remember where I was. They have a website? This is nice. This is helping me out. It's blinding. Compiles to standard C. That's cute. Oh, kit. Yeah, it's another word for baby fox as well. So that makes sense. Highly portable. Cool. Well, it looks great. I'm sorry. It died. But maybe I can steal this logo. Download it. It's mine now. My logo now. Yeah, so I'm just going to try to call this with something. They show an example here of, you can just, I guess, I can call it with the tags that I got for the children. My stream is skipping. I did put it up 1080p, and it sort of warned me that maybe I should only do 720p, and might be some buffering. And I didn't listen because I was like, I want more. I don't know. I'm going to be writing with tiny codes, so apologies for that. Maybe try refreshing. Otherwise, next time maybe I'll try lower quality. But 720p code is probably going to look pretty ugly, but maybe not. I can also get better internet connection, but that's actually impossible because there's only one provider and they're terrible. Damn you. What's it called? Spectrum. They're evil. All evil though. What have I done? I've done something bad. Oh no, good. What have I definitely did something wrong. I've undone something, but I'll fix it. LTTs. Oh yeah, because this doesn't make any sense. So basically, I need to call tag dot find tag, and I need to call class of, probably with any, because that's what anyone's ever called it with in the other versions. I don't know why that makes sense. I don't know what that's being used for. Hey, Arnold. Yeah, I'm do not have it set up right now. It's already seat of my pants, and quite shitty. I actually probably, well, let's LTDS, that needs to be there, that's for sure. And the question is what we put for this struct type here. And I just don't know. Something about the parent type, really. That's what they're doing. Maybe I could do that. Wait, but it needs to be it needs to be a light type tag. And I can't generate one the old-fashioned way, so I have to do this. Yeah, what did they do again? I keep forgetting this. It's too crazy. Make struct. They can make struct to do it. That's what they get back. They put in there. So I don't have a make struct. And we call directly on this strong declarations type make parse light type tag. Theoretically, I actually can do this. I can just call inspect on it, even though it doesn't. I'm not supposed to right now. So that's what I could do for now. I can call val struct expert. This quite makes sense. But I can call what was it? I already did above. The thing that I'm supposed to only do in the case of a fully strong type. Inspect of it. That will get me a light tag for that type. So inspect of type A, which, of course, then I need to get that type there so I can use it. So I have to say and type match. Then I get the case, not that, case A, and then I can do this. Woo! All right, let's see. Man, I hope this is something. Struct. And I think the last bit is optional. Yeah, it's a map, so I'll just do map.empty. Map.empty, are you happy? Oh yeah, I need to say dot as type. Okay, now implementation is missing. Where? Tag macro 53. Nope, not that one. 53. Oh yeah, duh. There. Cool. Well, I know this, but let me actually just do throw new error not supported type, which will say type ref, because that's kind of where we are now. And I'm not quite sure how to build out build the type ref back. I think there's probably a simple way, but just because I have to go momentarily, I'm going to try just to see what if I instead ask a tag of int and a. Theoretically, that might work. Can we do this? Tag of int and a. It's the same problem. No way. Unsupported. Wait, is it running again? Even? Oh, because the int part. All right. Let's just do a and B. B tag. So I have a tag for each of them. It's two types I don't know about. Can't find them. And I need two types of string int. Ooh, almost. Unsupported type ref. No, because it's going to keep. Interesting. I don't know why that happened. Let me see. Macro. Why would it try? It shouldn't try to find the int though, because that's weird to me. I just have to print out sort of my whole path of execution. But I think that the top level type in this case would just be the and type, and then inside of it would be either the A and B. And this one's going to summon that. Yeah, it shouldn't create tag expert 28. Yeah, it shouldn't be doing that, but it is. I'm going to print out at every line here what the heck's happening. So it's going to say make tag for typer. That's interesting. So it does try to get for the int anti-type ref So we're creating a tag with string, and it shouldn't be calling this because all parts should be strong of this. It should never call make tag. So that's weird to me. Let me print out if that's all parts strong. False. So I start on all parts strong because oh, true. Duh. Yay! No, not quite. It didn't work. Go, because this should be false. If it's a type parameter, it's false. I did it backwards. Nah, I did something backwards. If it's a type parameter, not all strong. Otherwise, all right, maybe not. Is at least let's see. Int is true. String is true. What's now? Wait a sec. Hey, it wasn't so wrong. It's mostly to do with some kind of typecasting here. And where did that happen? On line 27. Okay, so this bit. So before I cast it and say results, and I'm just going to print line results, and we'll just do results.show, and then I'll return result casting and it'll blow up. But we should see. Oops. Oh, yeah. So it called refine tag of pre any list apply. So I have a list of these two evidences, which is those things that are generated for A and B, and I'm inspecting that tuple in general. Sorry, that and type in general, and then I have an empty map. It actually looks fine. It's not perfect. Tag refine tag any kind. I might need to actually say as instance of expr of tag of A. Maybe it just doesn't know. That's just too narrow. It just this refined tagging just doesn't return something wide enough. Refined tag doesn't. Well, it returns tag of R. Oh, maybe I would have to give it a type there, but I don't know the type at that point, so that's kind of where you can't really do it. So you kind of sometimes have to hack things. And obviously it says it works, but if we look at it, it does say my tag is a tag of int and string. So it was able to actually get that. Whereas where we had before, it was a tag of A and B, it would have said. So some progress. Still more to go, but I'm glad there was some minor success here. Will it chain it? No. That's great. Okay. I have to go, but thank you for watching. Oh, I'm so sorry. I'm sure you just asked that a second before, but my brain is slightly fried and I must eat. I might continue a little later, but what I'm trying to do is solve this problem. I will post a link in the chat to what I'm working on. And it probably, once it's out, this will be a recording I went through. I was a little more cogent at the beginning. Yes, I'll wait. Yeah, thanks for watching. They are fun. They're pretty, it's mind-bending, but I'll do this again sometime. Thanks for stopping by, everybody. See you at Functional Scala 2021, Mike. And yeah, talk to everyone later. Good night.